Hello, Geometry Unit 1, Lesson 14. I know it's here somewhere. There we go. In Lesson 14, we are defining rotations a little bit more. So for this first part, we're just going to math talk comparing angles. So let's look at each figure and which pair of angles appears congruent. How would you check? So if I see these three sets of angles, it looks like angle ABC, which I could also say angle CBA, is congruent to LHG or GHL. And how I would write that? I could say angle ABC is congruent to angle LHG. I could also name this angle CBA, noticing that B is in the middle of each name because B is my vertex of my angle. LHG, I could also name it GHL because H is the middle of the name because it is the vertex of my angle. How would we check that? Okay, I could give you a handy dandy protractor and you could measure the angle. Protractors aren't very accurate, but it is one way we could do that. Another way we could figure this out is using our GeoGebra and a compass. Okay, it's really one of the easiest ways to do it. Sorry, GeoGebra and measurement. We could use a compass, and yeah, I can use a compass to copy an angle, and we'll do that at some point. It's pretty fun. Here, not really sure. It appears that YZM might be acute, a little less than 90 degrees, but LSR looks to be a little greater than 90 degrees, and KBP a little greater than 90 degrees. So these look to be congruent, where maybe the angles are a little greater than 90 degrees. Okay, here I'm comparing some Pac-Mans. It looks like those are. And I could say angle DVG is congruent to angle XJL because the angles look smaller to me. Figure 4. Ooh, that's a little harder, isn't it? Because we're comparing circles, and the bigger the circle, the bigger the angle appears, even though we really don't know, do we? So I'm trying to compare the outside of the angle. If I just compare the arc maybe, like from L to K and C to O, that's not really very accurate either. That one's tough. Well, the book says angle LHG and angle DEF. LHG is here and DEF is there. Yeah, you could probably see that better than me, but we could have used tracing paper. We have some of that in the classroom, and drawn the triangle and then slid it across to a different, angle. Drawn an angle and slid it across to a different angle to compare it. We could have used a protractor. Oops, the protractor like I told you. It's just a protractor, not protractors. If the circles were congruent, we could have used a compass. That would have been cool. All right, next in this lesson, we have an info gap. We have a very difficult time doing these distance learning virtually, so we are going to skip this for now. When we are in the classroom, we can definitely do this as a study, as using, to study for the next assessment if we're together. It's a great review. Kind of hard to do virtually though. And then that goes with that one. And then the last thing is turning into triangles. So we're going to practice this a little bit with our GeoGebra. The goal here is to practice applying the definition of rotation. In this activity, we're going to rotate a segment around its endpoint to create an isosceles triangle. So by rotating a segment around one endpoint, we can observe that the distance between the center of rotation and a point is the same as the distance between the center of rotation and the image of the point. Okay, this is how we're going to practice. So yeah, we're definitely going to use dynamic software though. So I'm going to go back to here, and I know I can always get math tools from my curriculum. It's going to pull up, yep, it'll pull up GeoGebra from there. Okay. And actually, it's not giving me all my tools, so I'm going to go straight to GeoGebra. I'm straight in GeoGebra. I'm opening up more. I think that's everything, just in case. All right, so let's do this. I'm going to look at your instructions. It says draw a segment. Label the endpoints A and B. So here I have a segment. That's going to be too big. A and B. Rotate segment AB clockwise around center B 90 degrees. So let's find our rotation. Instructions. I would think it'd be right here. See, we're not used to this one, are we? Lines, circles. I should push pause and look for it. Transform, rotate. So I am rotating segment AB around center B. It says 90 degrees. I don't know why we're going 90 degrees, but that's okay. 90 degrees clockwise. All right, and there we are. Label the new point A prime. Connect A to A prime and lightly shade in the resulting triangle. So let's go ahead and connect A to A prime and shade it in. I usually use the polygon tool to shade it in. What kind of triangle do we have? I have a triangle with two sides that are of equal measure, and that is actually an isosceles triangle. And I think that's what we're making, isn't it? Yep. All right. So isosceles, and this is 90 degrees. I can measure that if I remember where the measure is. If I measure AB and A prime, B prime, they're both 3.4. This one's not going to be 3.4, 4.8. We actually didn't know that. Didn't need to know that. But all right, step 2 says draw a segment, label the endpoints C and D. Rotate segment CD counterclockwise around center D by 30 degrees. So I'm going to rotate, see if we can find that again. So I'm going to transform, rotate. I'm rotating segment CD around center D by 30 degrees counterclockwise. And label the new point C prime. Rotate segment C prime D. Okay, this can also be considered D. Counterclockwise around D by 30 degrees. So we're going to do that again. Around this center, 30 degrees. Counterclockwise again. Label this new point C double prime. Connect C to C double prime. What have we made here? So if this is 30 degrees and that's 30 degrees, we know the whole thing is 60 degrees. We also know that C D double prime and C double prime D double prime are all the same measurement. We can do this right here. 3.3, 3.3, and 3.3. It's hard to see, isn't it? I can move that number. Cool. I could also measure my angles. I know that the one I constructed was 60 degrees. Of course, it's going to give me it out there. That does say 60 degrees. Nope, need a pointer. I've never figured out how to label my angles well. Somehow I always mess it up. So if I measure this angle, 60 degrees, 60 degrees. So what do we have there? We have an equilateral triangle. It's also equiangular. Equilateral and equiangular. Those are all the things that I notice. Awesome. Let's go back to the lesson. I'm pretty sure we caught everything. Did I just close? This isn't the right lesson. I think I may have just closed it out. Oh, for goodness sakes. Then let's go here. Here's your lesson. So we didn't do that. We did this, turning into triangles, and then we have our summary. Okay, we did a lot of copying and rotating here, and that was it. So 3 sort of short lessons in a row make up our translating and rotation segment of our Unit 1. All right, good job.